you just start doing this text data pre-processing, right. So, for other data we will do it quickly, right. So, we will tell you the steps, we will share you some documents, right. So, similar to the text data, so we have different pre-processing technique for time series data, for video data, for audio data, right, for image data. So, you just the task is in pre-processing that you just transform your raw data, whatever you are scraping, right. So, that we generally called raw data. So, once you have raw data with you, try to transform into vector space. Okay. So, just do these things. So, I think it will give you little brainstorming that what are the steps required. So, this is specific to text data, but the similar things are in other language, other basically data sets, image, videos, right, time series. Okay. So, you just do it. It might take time because it downloads a certain things from the database. So, punctuation, stop words, wordnet library, it basically try to download to your own local system for analysis. So, here it is because you are using Colab. So, Colab VM that is allocated to you. So, it is installed in that by the way, right. So, in this runtime session you will have that thing. Maybe you can put in Google Drive as well if you want to store it. Right. So, next one is basically you just read a sentence here. So, you can say that whatever you have scraped. So, I think the news data you have scraped, right. So, just put that news data here and just see how tokenization works. How can you do stop word? How can you use stop word? All right, to remove the words which you do not like or which is not required for the prediction or inference, right, or analysis. Do lemmatization, do stemming, right, do lowercase. You might remove the words which are which are basically small length. For example, 2 character words you can remove. Maybe you can remove special symbols like dot, comma, inverted comma, right, hyphen you can remove, curly braces you can remove. You may remove basically numerical values, numeric symbols you can remove. So, if you want, so that depends at what type of task you want to perform, right. So, you can put in that stop word list, accordingly the data will be cleaned. Just do it and see that how the data is represented. You can see here after tokenization your data is simple splitted into words form. So, what are the words available? So, that is why the first vector representation that we are going to discuss about the this basically text data, we call it bag of word model, right. So, BOW, so bag of words. So, where we do not think about the order of the occurrence of the words or the tokens in the data, but only their presence or absence we are interested in, or their frequency, how many times they occur in the data we are interested. So, that is very simple tokenizer. You can say that only the spaces here are used to basically split the sentence or text. In other languages, maybe suppose you have a Hindi language, you might have a French, you might have a Bengali. In other languages, you can see that what are these basically splitter or you can say delimiter. So, accordingly you can just design different tokenization algorithm. So, for different languages you might have different. For many languages the same tokenizer might work, right, but for some specific language like Urdu and others, you might go for different tokenizer. You can write your own regular expression to get the tokens, to get the word, right. So, regular expression based tokenizer you can just design. So, here we are just giving the demonstration on the English language, but the same is true for the Hindi language. You can crawl the data, you can get the indic library is there, right. So, for Indian languages you can get indic library. So, lot of for lot of languages we have tokenizer there, right. So, if you are interested, you can use them as well. So, your sentence will look like this, right? Splitted in the form of tokens, in the form of word. You can say here, you can see here. So, we have punctuation also, right? All the words are here, right? That are used in sentence. So, in pre-processing techniques, many times you want to remove punctuations. Many times you want to remove certain words like is, aim, or the. You can use stop word list to basically remove them. Maybe naturally you want to basically every word that you have, every token that you have, you want to represent, you want to use them in lower case. Otherwise, if n is capital and you have another word which has lower case n, so both will be different. So, before creating dictionary, so because otherwise your dictionary size will be huge. So that's the only thing we do is stemming and lemmatization. So, because many form of the words, so we are converting into the base word. So, the dictionary size reduces, right. So, that is the idea. So, after pre-processing you just form the dictionary and you just represent your data in vector form, that is a simple thing. So, just try to execute it. So, instead of this sentence, whatever you have crawled, you just put that text, right. Then stop word, of course, you just see that in your data you might feel different stop words. So, go to the stop word file, or you can supply stop word list as a list here. Instead of file, you just provide as a list. It will try to basically stop it, right, remove from the data. Okay. Then stemming you just do. For lemmatization, you can use the WordNet library. So, WordNet is a English database, you can say lookup database for English language. So, it has basically grammatical structure of every word. So, every word with its associated forms, that information is available in WordNet library. So, idea is if you have a word go, went, gone. So, basically lemmatize, or you can say represent all its forms, right, into base form. So, if you have went, it should be replaced with go. If you have gone, it should be replaced with go. If you have goes, it should be replaced with go. Likewise, if you have a grammarly, so you have to represent it with the base word grammar. So, the idea is to reduce the dictionary size, otherwise grammar and grammarly will have a different word in the dictionary, right. So, later on we will discuss when we discuss other semantics, maybe sometime we need semantic, then it depends, right. So, whether we should remove or not, because they might have a different semantic, or you might have a different translation. So, in translation we do not perform stemming or lemmatization, because we have to preserve the grammar, we have to preserve the structure, right. So, otherwise you cannot perform translation. So, we provide the exact sentence as input, right, and the algorithm, the approach, the models that we use. So, they try to capture that context information or the positional information in which the tokens are present in the data, right. So, in the modern architecture, positional embedding you might have heard. So, maybe if you have done coding on transformer. So, positional encoding is one of the way we basically try to capture, right, positional information or context information in the text data, and that is true for all temporal data, right. So, for text we have transformer, for vision data, computer vision we have vision transformer, right. Maybe in due course of time we will discuss that. So, use this thing and see that how what is the output you just try to display, right. Then, so after this generally what we do, so this is just bag of word representation, just pre-process it, then create the dictionary. Next step is to create the dictionary and represent every document in binary form or frequency form, third frequency or TF-IDF matrix form, right. One or two more instructions are required, and you can just do that, right. You just do this and practice it. So, next one is simple visualization. So, just try keep on doing it. So, all the codes are with you right now. Just see if you have some data set with you, you try to visualize. So, this is some libraries. So, matplot is one of the popular library in Python, right. So, you can use matplot library to right. You have a pyplot, you have functions, right. So, you have a matplot and maybe some other libraries are also there. Data visualization share nahi. So, generally if you want to do visualization in code, so we use this matplot library, matplotlib. Just go and just see that how the plots you can generate the plot, how can you basically plot histograms and many other things, right. You can, so this is a scatter plot, right. You have a data, you can plot it. So, just see, so this is little brushing up about the visualization tutorial. So, can you see this visualization? You just see that how the plot. So, basic plotting you can just write. So, these codes will be used maybe in tomorrow's session. These basic codes when we do the visualization of optimization algorithm. So, we will see that every step how optimization algorithm works, how the loss function basically converges, how it is minimized, and different algorithm has different flavors. So, different way, different things, right, and different convergence and convergence mechanism, right. ये आप लोगों ने कर लिया? ठीक है. Then one document that I shared, right. So, that is compare algorithms. So, where we assume that we have data in tabular form, that is CSV comma separated values, right. So, likewise you might have many other form that you can directly read to the matrix or vector. So, if your data is processed in some sense and you can directly map it to the vector representation or matrix or tensor, you can directly use the algorithms. So, that one is that if you have a data very structured form, you can use it and you can compare the algorithms, machine learning algorithm that are, most of them are very popular one that we have used. Logistic regression, SPM, right, multi-layer perceptron, naive Bayes and random forest, right. So, you can see there and you can see that same data set, same split. So, different algorithms performs differently. So, one question might arise that why these algorithms have different accuracies. They all are doing the same job, right, but why? So, we will try to get answer in the coming days. So, when we do the optimization, we will tell you that these are the methods most of the algorithm or these algorithm uses, because the way the algorithms are written, the way they optimize their problem. So, that basically carried here to get the accuracy, right. So, that one is this one, compare algorithms. So, this visualization you can do this one. Maybe I can increase the font, right. So, I have also saved one data set, right, Pima Indian diabetes data set. So, you just how will you upload it? One way is to basically put in the Google Drive. You just copy the path, you mount drive here in this executable, or you can say this ideally. You can put that path in the data set where you read the file. So, here in the file name you just put the complete path, right, like content slash drive slash. Otherwise, you can just choose this folder. Of course, you have to mount, you have to use it. So, choose this folder symbol here. You can directly upload your data in this runtime. Right. So, just go here, click here, right. So, just go here, this symbol first one, go to the folder where your data set is there. Maybe I am just writing here Pima Indian because we have many files. So, one of them I am just choosing here. Okay. Right. So, now it is in the current, it is in your current directory. So, if you want you can check it, right. So, at any point of time if you want to check anything you just see it. So, what is the current directory? You just do pwd. So, these are a Linux command. Content is the current directory. Then next one you just say that okay, what are the content? You might get many content by one, right. So, execute it. Yeah, right now PMI and average. So, use this file name. Many times there might be some spaces, some differences. So, you might not identify. So, copy it from here, put it here. Okay. Now, just try to execute. So, this one, right. Then of course, you just see here. So, this data set has 8 features including its class label, right. So, the last one is the class label. So, that is why y is basically the class label, x is the data. So, we are just taking index 0, 1, 2, 3, 4, 5, 6, 7 as a feature, and last index that is 8 we are taking as a class label. So, you know the indexing mechanism in Python. So, how we read these columns, right, and number of rows, how can you, so all the rows and these columns we are fixing. And these models we are comparing here, you can add more, right. So, logistic regression, because this is a classification data set. So, we are going to compare the classification models. LDA, linear discriminant analysis, k nearest neighbor classifier, decision tree classifier, naive Bayes. So, actually data that we have is not discrete in nature. So, you can use Gaussian naive Bayes or multinomial Gaussian naive Bayes here. SBM is supported to machine with some parameters. So, parameter, every model has certain hyperparameter. So, that is defined by the user. So, you can go to that package, that particular instance and put those parameters. So, when you put your cursor there, so it will provide you the description of that particular model, right. So, for example, you just suppose you say that you go to the decision tree or cart, this one, it will tell you that what are the parameters you can put here. So, every model you just go and you see. For example, here in support vector classification, you can see that what parameter you can do here. So, default values are always there. So, you can change it, right. So, kernel is RBF, you can say linear kernel or something else, right. Tan H you can say is gamma equal to, you can say that is scalable, or you can just put the gamma value here. Then random forest is there, so you can just see that what are the parameters. So, these all are whatever you are providing here in this parenthesis during the design. So, these arguments are mostly the hyper parameters. So, it is specified by the user whenever you are calling that method, that function, right. So, you have to pass these values. So, most of them are by default. So, we put the default values, but if you want to change it, you change it. So, all of these are hyperparameter. So, the model performance depends on these parameters. Any model that you are choosing, if you choose these parameters in a better way, in an optimal way, so algorithm will give you the best possible accuracy that the algorithm can do. This is a very challenging task, and there are only few methods to deal with this problem, because exhaustive search of course you cannot do, it is infeasible in practice, right. All possible values you cannot check. So, idea is people go for grid search. So, for every parameter or 2 or 3 important parameters, you just provide a possible list of values that you want to test. You test with those combinations, and if you just find that which set of parameter gives you better accuracy or works best, choose that one, right. So, this is optimization problem. So, people use grid search is one of the way. So, we generally miss many things there. Another one is random search. If number of parameters are huge, whatever you do, just say that okay, just 1000 random values you just try for all the parameters and come up with a good set of parameters out of those 1000 or maybe whatever limit you have, computation limit you might have. Just say this one is the good one. The next one is the heuristic algorithms. You can use genetic algorithms, you can use differential evaluation. In Python, you have differential evaluation method. You can use particle swarm optimization. You can use end colony optimization. You can use V colony. You can use whale optimization. You can use crow search, right. So, all the heuristic algorithms. So, in the first session, we said that you can use AI for constraint satisfaction problems. So, here in order to get, because this is you do not have a deterministic, we have deterministic algorithm, but it is very very costly, right, in terms of time, right, it is not feasible. So, idea is can we use heuristic. So, nature inspired algorithms or heuristic algorithm you can use here in order to optimize the hyperparameter. So, you can see that you can go to the web and you will see that lot of papers, research articles, top class articles on this one. You just come up with a good heuristic algorithm which can do the hyperparameter optimization, you can get a good article. So, people in soft computing or nature inspired algorithm, they generally do this type of task, where deterministic algorithms basically are time consuming, they are not time efficient. So, at that particular point, heuristic algorithms or AI based search algorithms try to do best in practice. Many times people ask questions, so do you have guarantee? So, of course, when you use heuristic, many times guarantees you cannot expect, there is no guarantee. So, that is why I said that there are two more things in addition to the complexity. One is the quality of the solution, that we call it optimality. So, many algorithms might not be optimal, but they might be acceptable. Suppose I say that you have to reach from NIT Hamirpur to IIT Jammu, and I just roughly say that okay, if your travel cost is around 2000 rupees, it is acceptable for me. Then you can plan, right, accordingly. You can you can choose a non-optimal path, but it works for you, right. It might be little faster even, right. So, in terms of distance it might be little longer, but in terms of time it might be faster. In terms of your willingness, right, it might be more suitable. So, that is why we said that your algorithm might not be optimal, we are not always interested in optimal, but we are interested in real time solutions which is complete. Complete means it should not happen that you choose a path, you choose a method which does not lead to the solution, even solution exists, right. So, here you have to guarantee you will ensure that solution exists, you will give some solution, but that might not be optimal. So, heuristic search, that is if you are doing research, so this is one of the open area where people do this. So, when we do this neural network architecture, we will discuss in the coming sessions. Hyperparameter optimization will be a challenge. So, there also we use the same trick, right, but only the challenge with the heuristic optimization is that you choose one set of hyperparameter, you call this algorithm, execute this algorithm on your data, then choose another set of parameter, train your model on that same data, choose another set of parameter, and just see that on which set of parameter your model is giving good results, you just choose that one. But because you can see here you have many hyperparameters and many of them are in continuous scale, so how many values you will try? So, domain is infinite, right. So, minus infinite to plus infinite, how many values you will test. So, that is the challenge that pose the infeasibility, or you can say constraint here, time consuming. So, that is why these are the few methods: grid search, random search, and one is the optimization, heuristic based optimization algorithms. Whole class of nature inspired algorithm or soft computing you can apply here, and you can get a very quick paper, right. You can come up with a different heuristic also. So, you can get a different maybe very good article in optimization algorithm, right. So, like GICO is the one of the star conference in soft computing, and all the AI conferences except paper who are which basically works on heuristic optimization, right. AAAI, UAI, SKY, right. So, ICML, NIPS, DubDub, CICM, ICDM, right. So, many. So, all the venues basically accept the paper in this heuristic optimizations. So, now just see here. So, you can put the parameter now you know. So, we are using mostly the default values of the parameter. You can do the grid search. So, library has the facility of that. You can use random search, you can use differential evaluation, is one of the nature inspired approach that is inspired from the genetic algorithm, right. So, this Python library has that one. Maybe you can get many more other libraries, other codes in Python. So, you can use for this hyperparameter tuning. Okay, just see here. So, this is a data states that you have, what is the mean, variance and distant deviation, right, you can say. And we have here basically 10-fold, I think how many folds we have used here, 5-fold or whatever number of folds we will discuss maybe in data pre-processing. So, generally in order to ensure that your model will work in real time, we do cross validation. So, we will discuss more when we do the optimization, right. Then you can see here, you can execute and see this one. So, you will get the results. So, this is just visualization of the result, box plot and this. So, just try to execute this one. Then one thing you can see here, so different algorithms. So these are the basically 5-fold cross validation accuracies. Logistic regression has 76.3093%, and variance across the, or standard deviation across the 5 folds, because every fold you have accuracy. So, average it out, you will get mean and variance. So, in the parenthesis you have variance. So, how much it basically deviates across the folds, and the first one is the mean. So, mean accuracy is 76.30, then discriminant analysis has 76.96. These all are on default parameters, right. You can tweak the hyperparameter, you might get a little better accuracy, right. Then KNN 72 point something, CART 69.93, NAB base 75 point something, SBM 65 point something, and random forest 70 point something. So, which one is better? Which one is better? LDA. Should I publish a paper? By saying that LDA is the best algorithm here. Right. See, so it seems that it is performing well here, but we have not used fundamental concepts of experimentation. Right. So, fundamental concept says that you have to assess every algorithm what it can do, what is it is basically capable of, the best thing that it can do. For example, logistic regression, suppose you do hyperparameter tuning using some heuristic optimization, grid search or random search algorithms, you might get good accuracy. This accuracy you have got on the default values of the hyperparameter. So, if you fine tune the hyperparameter, so there is a chance that other model might be the winner, right. So, that is the thing you have to do. Then another thing is remaining here, we have not performed the statistical analysis. What is the confidence in saying that this model gives 76% accuracy when it will be deployed in real time? So, what we did here, so we have data, we split the data into 5 parts, we trained the model on 4 part, we tested it on 5th part. In this way, every part that we have in the 5 parts, we call it fold. There are 4 parts are treated in training, 5th part in testing. So, we have 5 settings such, right. So, every part is basically is used once in the testing part. You get the accuracy on the testing part for every such a split, get the average accuracy. So, maybe your data set is very small, let you have 100 samples. So, will it be better? Can we say number of splits might be 10, so will it be same? So, you might see that different algorithm might be the winner. So, it means that your model is not stable, right. So, if you are, it is not generalized, right. If you are splitting more, splitting less, accuracy is not stable. So, that is the challenge. So, how will you do it? So, there are many methods in standard machine learning models. Generally, people go from leave one out cross validation. So, if you have a small number of samples, people say that you just increase the split and you just say that every sample will be used for test, right, once. And how many samples, if you have, let you have 100 samples, so 100 might be the number of splits. So, that is leave one out. So, leave one out. So, one sample you just keep out for testing and remaining sample you just use for training. In this way, just do the similar thing, like you just test your training and testing split, you have one sample in the test, keep on doing it, get the average accuracy, that is leave one out accuracy. Even that is not the 100% correct, but it gives certain insight. Right. So, only the thing statistically you can see here. So, variance that you are getting out of many folds, if it is small, then it little signifies that your model will be little stable, robust in some sense. So, generally what we do, I am just giving you the research trick, how can you publish paper. You have a data set, split it into folds. So, first thing is split into training part and testing part. Testing part keep aside. In the training part you just do whatever you want. So, perform the cross validation on training only. So, testing data should not be used for any kind of hyper tuning, or you can say any kind of learning method, learning process. Test data you just keep it out, right. So, just whatever you can do best for the model using hyper tuning, using some other strategies, you just assess the model accuracies, right, and execute for one model, execute for many times, right. Do not fix the seed, random seed, because many algorithms use random numbers. So, if generally for parameter initializations, weight parameters. So, if you fix the seeds, so every time you will get the same result, right. So, do not fix the seed when you are training the model, because you have to learn the generalize the model, you have to train it well. You just execute many times, run it many times. Suppose you have trained the same model, get the accuracy 100 times. Every time you will execute, you will get different accuracy. You just compute the mean, you compute the confidence interval. So, your model will be statistically validated. Just compute the, if you are comparing with two algorithms, now you have 100 element vectors. So, 100 test accuracies, right, or even you can say cross validation accuracies you have for one model, 100 for another model. You just compute the t test. You just see that how different the mean of those two vectors are. If they are significantly different, right, you can say that two results are significantly different, right, and the one who is better, you just declare that this is significantly statistically it produced significantly better results. So, this model is the winner. But everything you have to write, you have to say that what method you have used to perform the experiments. Otherwise, you cannot compare, right. So, that is the standard way. Once your model you have found the best set of parameters, good set of parameters, hyperparameters, you just train the model on the training part, and whatever you have kept aside earlier, you just assess the accuracy or you can say performance on the test data. Now, take all the models, do the same thing and get the comparison. So, which model is working better on the test data, right. So, this is one story, but it has certain challenges. So, that how many samples do we need? So, we will discuss in tomorrow session. What guarantee we can have if number of samples we have 100 or 200,000 or many thousand, right. So, that depends on the data domain, what type of algorithm we are using, right. So, there are some statistical measures we try to assess the model performance, and we try to basically say that this model is better for this task, and we come up with the articles or publication. Otherwise, if you send your paper to good venue, if you have not followed the standard procedure of experimentation, so many times when the papers come to review, so we just read the abstract, we read the experiment section, and if we see that there is some flaw in the fundamental procedures of experimentation, generally papers are rejected, because we cannot trust on the results, right. So, that is why you have to follow step by step procedure that we have for experimentation. ऐसा नहीं कि data उठाया, just take the data. For example, here these results, you cannot declare who is the winner, because we have not followed standard experimentation. What we did, we have data, we have algorithms, we applied the algorithm blindly, we got the result, and now we are saying that this model is better. You can critique anyone, right, if you know everything about the person, that thing. Otherwise you cannot critique, right. So, here the same story is, if you perform experimentation for all possible values of the hyperparameter, then of course you can 100% with 100% confidence you can say that this model cannot do better on this data set, right, for this particular splits. You can guarantee then and because that is infeasible, that is an exhaustive search of hyperparameter is NP hard problem. I think many of you have done data structure algorithm course, you know that what is NP hard. So, in practice it is infeasible, right, in real time or the computation unit that we have. So, that is beyond the capability of those computation units, right. So, that is thing. So, we have certain statistical methods, certain heuristic to do this one. So, I think what is the time right now? 4:40 I think maybe. So, you just try these algorithms on your own, maybe you can come up with you just put your own data, maybe arrays CSV. So, any CSV file you just do it here, only the change you have to make 2 lines where you have data X, you just see that what are the columns you have to put in the X and which column you have to use in Y, right, that you have to just put there, and then you just try these algorithms, right. Then maybe grid search, and you just try to read grid search, random search and differential evaluation in Python library, sklearn library you have that. Okay. So, maybe I will share one code, you will see that if you apply those things here on this, definitely you will see that random forest might be the winner on this data, will 80 plus accuracy, right. So, most of the models will get 80 plus accuracies, right. That we will see that if people are able to do or not in the tomorrow session, right. Okay, we will share many more. So, one thing I have said here, I want to tell you, which one is that, embedding projector. So, if you want to visualize the vectors, right, data vectors, feature vectors, you just supply them as a file here So, this is one of the MNIST data, I think, right? Yeah. So, this is just digit data. You can say we have used PCA to visualize it. You can this is interactive, right? You can upload file and you know that steps are there. So, you can see here how can you basically just do it. Text data is here, right? So, this is word vector embedding projection of text data. Okay, you can go to the different algorithms, right? So, TSN is little, it will take time, so you can play on your own. This is another code that I have said. So, this will demonstrate, I think it will be better if you basically practice this one. So, how neural network basically works? This is an interactive basically demonstration by the Google TensorFlow, by the way. If you change the weights, initialization of the weight initialization, it should change the basically activation units. You will see that different models you can get here using the neural network, right? Even optimization algorithm will change. You will see that accuracy basically you will get different accuracies. So, these things will give you little intuition. So, in this talk will give you the intuition why the model works, how the model works. Then you can decide when to use the model, right? And mostly we will discuss about in the context of attacks and defenses. So, for building the base, you should know how to basically create model, right? How to generate models, how to train, how to test. Okay. So, that is please do it on your own. Maybe many of you might have used it in previous, but just for illustration, just for demonstration, I have just shared these libraries to all of you. Okay. So, we can stop here, I think. So, all right. Maybe you can ask question. We can take some questions. Have you done all these? Executed all this? Now the task is not limited to this one. You just go understand it. Use your own website to scrap it, right? So, maybe one assignment I am just giving to all of you. Just go to some ClickBuzz site, right? ClickBuzz, I think everyone knows. So, they lively demonstrate the cricket score, right? Live match and cricket. So, just try to just display the current score, number of wickets, what is the score, which team is playing. So, just write a script in Python which regularly monitors, scrap that website, maybe every 2 seconds, right. Every 2 seconds you just scrap it, scrap only the required field, you just display the score. Then if you want, so there is one library in Python itself, you just send the message as basically text as a message, score as a message to any mobile number that you are interested, right. So, this will be some live script. You will see that from text data how can you basically do the just simple analysis and you can send the score, right. And of course, you just play with these tutorials that we have in today's session. Okay. Yeah, thank you. I think time is up, right? So, as per the time, we are on time or not?
We are beyond the time.
Oh, thank you.